So we have what we can do in this case is we can move everything to one side, set it equal to 0, change it to exponential and solve. Or there's this other way we can do it, type 2. Because these are all like there's no number. In the last one, you guys, in the last one's back here, it was always equal to a number. So you had to get this side together, change it to exponential and solve. Get this side together, change it to exponential and solve. And then you had to make sure that you could get common base, okay? So for example, I'm just going to do this one up here quickly. We'd have log 9, 3x equals 1. Change it to exponential, so we go 9 to the 1 equals 3x. Divide by 3, and x equaled 3. And we had to check back. Okay, 3 goes in here, that's fine. So it works, right? We check it. We also check. So if it's equal to a number, we have to literally get everything that's not the number to one side, put it together, and then change it to exponential. That was that one. This one, though, however, this second type doesn't have a number, right? It's just all logs of the same base. So what you can do is you can combine the logs on both sides together first. So here, because they both have 1s in front, positive 1 and a negative 1, we can put them together. If they didn't, we'd have to take those numbers, move them up to the exponent, then put them together, right? So it's going to be log, and then this would be, I'm going to put base 10, because whenever there's a base, I'm going to put the base 10. This is going to be x over 15, because if it has a plus 1 in front, it stays on the top. If there's a minus 1 in front, it goes to the bottom. And then this equals log base 10 of 0.2. Now, why is this way easier than the other way? It's easier because now we have a log equaling a log. We have log base 10, log base 10. This is in the brackets, this is in the brackets. So then what can we say for this to be true? That whatever's in this brackets must equal this, correct? So you'd have x over 15 equals 0.2 times by 15. X equals, is it 3? Yeah. Then we check. Take our 3, put it back in. 3 is besides log, that's going to work. We can check it and see if left side equals right side, and it does, you're good. Remember, you can't have a negative log and you can't have a negative base. Remember that? You can't fill it in there and get negatives. So you have to always check when you're solving for logs. Everyone forgets to do that. If you're someone who's like, yeah, I totally would. Star, 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 star. Sticky note. Highlighter. I don't really care. Remember to check when solving for logs, because you might get an extraneous root. Remember I told you they could just ask you to find the extraneous root? This one here, logs, logs. There's no just number by itself, not like a +1 or a +7, right? So if we have something like that, then we can get all of the logs together on this side, all the logs together on this side, and as long as they have the same base, we can set what's beside them to equal, right? So this is a 1 in front, a 1 in front, and a 1 in front, so that's good. This is log base 3. Both of these have positive 1s in front, so they're going to stay on the top. X minus 1 equals log base 3 of 6. Then we have log base 3 of x squared minus x equals log base 3 of 6. So what can we say if this is true after this step? If this is log base 3, this is log base 3, then whatever's in this bracket must be equal whatever's in here, right? So now we can say x squared minus x equals 6. Grade 11 coming back at you. When you have an x squared, what do you always have to do in order to solve it? Move everything to one side and set equal to 0. X squared minus x minus 6 equals 0. And you factor it. What times what gets me negative 6? What plus what gets me negative 1? X minus 3. X plus 2. We don't have to do decomp because there's a 1 in front of the x squared. If there was not a 1 in front of the x squared, you have to replace your middle term with a 2. then group them, then solve to do decomp, right? So we're going to get x equals 3 and negative 2 when you solve these. But we have to check. Okay, I take the 3, I plug it back in. I get a 3 beside here. 3 minus 1 is 2. Okay, that sounds okay. Plug in negative 2. Log base 3 of negative 2. Can I have a negative 2 beside it? No. Can I have a negative 2 in the base if this was an x? No. This one's out. It's extraneous. If you plugged it into your calculator and you went log base 3 of negative 2, it will error you. It'll say it's not happening in calculator talk. Okay? What's my biggest issue with this one? How is it different than the other one? There's a 2 in front. And you can't have a 2 in front and say that they're the same. So if you did do this, say you went 2 log x equals log base 3 times 27, and you tried telling me right now that x equaled 3 times 27, which is 81. Is that true? No, because it has to be log base 10, this. Is it the same? Is there a 2 in front of this one? No. So I have to bring the 2 up here first. After bringing the 2 up, now I can say that x squared must equal 81, right? So x squared equals 81. Remember when I square root, what do I have to do? Plus or minus 81. So it's going to be plus or minus 9. Now, some people say negatives are always out. Well, you can't always say that negatives are always out because let's say, for example, it was x plus 3 and you got negative 2. Negative 2 plus 3 is positive 1. You'd still be okay. So you have to check them. So I take my 9, I have a 9 here. I take my negative 9, I have an, not good. Check that out. So x equals 9. X equals negative 9 is extraneous. The reason why I'm writing that is because they can ask you for the extraneous one to make you actually have to solve it, right? Because could I not just y1, y2 this? Second trace 5, enter, enter, enter. What's my only rules in order to do that? There has to be an equal sign in between and only one variable. Is there an equal sign between? Yes. Is there only one variable? Yes. Could I have an x here and an x here and it still work? Yeah, as long as the only variable is x. If I had like an x and an a, I couldn't type it into y1, y2. But if I have an x squared, and an x cubed, right ahead, y1, y2, as long as there's only one variable, like one letter. Okay? That's that one. Okay. Can I just get the logs together on here and then everything together here and then match our brackets? No, I have a minus 3. So what do I have to do when I have a minus 3 or a number by itself? I have to move that to one side and keep the logs on one side. So, and I need to move this 2 up as an exponent. So I'm going to get log 3x squared minus log 3x plus 3 equals 3. Could I y1, y2 this? Does it have an equal sign? Yes. Does it have one variable? One letter? Yes, I can y1, y2 this. Wants to 2 decimal places? Absolutely. You're not going to do that today, but you can do that if it's on the diploma like that. How do they do it? Here's all these steps. Blah, blah, blah. Tell me where you made a mistake. Or give me the extraneous root. It's a good one, too, because that forces you to have to do it algebraic. Okay. They have ones in front of them, so we can put them together. Log base 3. X squared stays on the top because it's positive. X plus 3 goes to the bottom because it's a negative 1 equals 3. What do I do for my next step? If I'm looking for the base or the value beside it on a log, I have to change it to exponential. So I'm going to get 3 to the 3 equals this lovely bracket. 3 to the 3 equals x squared divided by x plus 3. Not sure why I wrote it in brackets, but I did. Then we have 27 equals x squared divided by x plus 3. What am I going to have to do? Multiply by what? X plus 3. Then I get rid of the ugly fraction. So now I'm going to have 27x plus 81 equals x squared. Now I have an x squared. What do I have to do whenever I have an x squared? It should be drilled into your head from grade 11. Move everything to one side, set it equal to 0, and factor a quadratic formula. So I'm going to get 0 equals x squared minus 27x minus 81. If they wanted you to do this fully, you'd have to quadratic formula it. I'm not going to make you do that. So plug it into your calculator and get your 2x intercepts to 2 decimal places. So you're going to get one negative and one positive in this case. Do you always get one negative and one positive when you factor? Does every graph always give you a negative x-intercept and a positive x-intercept? No, you could have 2 positives. So the first one is negative 2.72. If I plug in negative 2.72, does it work? It works for this one, because I still have a positive, but it doesn't work for this one. So that one's out. And then the other one's close to 30. $29.72. This one, you'd go log 4, because they have plus and minus 1s in front. You get this. Equals log 4, 8. Because they're both logs, I don't have to change this to exponential or anything, right? I don't have a random just number that's by itself that I need to move to the other side so I can change it to exponential. When we get the same thing that I did last time, x plus 1 over 2x minus 3 must equal 8. Then I'll have to bring my 2x minus 3 up. X plus 1 equals 16x minus 24. And then this one's nice because it's not a quadratic. Minus x. At 24. 25 equals 15x. And you can divide by 15. Check your 5 over 3. 5 over 3 plus 1 is good. 2 times 5 over 3 is bigger than 3, so that's good. So the rest of this is your assignment. And that log tangent